Man, this is a really great question. If thorium has a half-life, the age of the universe, how in the world could you measure that? How would you know, right? You'd have to wait 10 million years just for a fraction of a percent of it to decay. So you're not going to see it. In our lifetime, over the recorded history, it's still going to just decay a tiny little bit. And who measured that? A really great question. So the way that we do that is through secular equilibrium. Now, the radioactive decay law is given right up there, where that L that you see there is actually the decay constant. It's the probability of decay per unit time. And what happens is, if thorium has a certain amount of radioactivity, we can measure a certain amount of radioactivity of the thorium, and it decays through different progeny. It has radioactive decay products that decay all the way down into radium and then radon, and then that decays down into lead. And the point is that the laws of physics say that if I have a closed system, like say I have a grain of crystal, like from granite or something like that, and if that grain of crystal has been closed since the thorium was placed in there, then eventually, as the thorium decays, it's going to create other radioactive decay products. And if those radioactive decay products have a shorter half-life, they will very quickly come into secular equilibrium. And what that means is that the decay rate of the thorium becomes equal to the decay rate of the progeny. In other words, it's kind of like filling up a sink with successive sinks below it. Eventually, the flow of water is going to be constant throughout the entire system if the original source is constant, like the radioactive decay of the thorium. If that source is continually constant, then eventually all of the decay products will have the same amount of decay. And since the decay equation here still applies for all of those isotopes, the only thing that's changing is the half-life, that L. That's the thing that's changing. That's actually the reciprocal of the mean lifetime. And so that's changing, but the N, that's the number of atoms that you have, and we can measure that with a mass spectrometer. And since we can measure the activity of all the progeny, and we can measure the number density of all the progeny, we can get then the decay constant of all of those. And again, the reciprocal of that decay constant is the mean lifetime, which is natural log divided by the half-life is the decay constant. So that's how you do it, is you just use the laws of radioactive decay. And if it's a closed system, like a fixed crystal of some sort, like a single crystal, and you know that that's been a closed system since it was formed, if you find one that's really, really old, then you can actually measure the decay series that's in there, and so infer what that value is. So great question. Thanks. Keep them coming. Have a good day. Bye.